No. Refraction through prism. So here ABC is a prism. Call it a prism. So A, B, C is a prism. Okay. A, B, and AC are refracting surfaces. ABC is a prism. AB, comma AC are refracting surfaces. Okay, they are refracting surfaces. Okay. Now, BC is the base of the prism. BC is the base of the prism. BC is the base of the prism. Okay. Now, you have two normals. Now, suppose this is the incident ray. Right, PQ is the incident ray. Okay. Now, I am drawing a normal. Normal is a line. Normal is a line perpendicular to the surface. Normal is a line perpendicular to the surface. Similarly, here also we have normal is a line perpendicular to the surface. Okay. PQ is the incident ray. Here, PQ is incident ray. Incident ray. QR is the refracted ray. QR is refracted ray. And RS, this is QR and this is RS. Okay. RS is what? It is emergent ray. RS is emergent ray. Here, PQ is incident ray, QR is refracted ray, and RS is what? RS is emergent ray. Now, so here this is normal, N1 and N2, both are normals. Okay, and here A is said to be angle of prism. Angle A is said to be angle of prism. Here angle A is angle of prism. Angle A is angle of prism. Okay. Now here this is said to be angle of incidence. This is angle of refraction R1, R2, and this is angle of emergence. Angle of incidence means angle between the incident ray and the normal. Angle between incident ray and normal is said to be angle of incidence. Angle between the refracted ray and normal is said to be angle of refraction. There are two angles of refraction, and E is said to be angle of emergence. Angle of emergence is angle between the emergent ray and the normal. Okay, angle between the emergent ray and the normal is said to be angle of emergence. Okay, now here A is said to be angle of prism. So here I will write I is incident angle or angle of incidence, angle R1, angle R2, refracted angle of refraction, Here angle E is said to be angle of emergence. Okay. Now here we will start now. A, Q, and R. I will take N as a point. This is a normal. The two normals are intersecting at N. Okay. So here what is it? A, Q, and R. What is that? A, Q, and R is a quadrilateral. Okay. A, Q, and R is a quadrilateral. Okay. A, Q, and R is a quadrilateral. See this one. This part. See carefully. I just make it a little thicker so that you can understand. Okay. Is it clear? A, Q, and R is a quadrilateral. Now, in that, the sum of the angles in a quadrilateral is how much? Is 360 degrees. Okay, 360 degrees. But what happened here is there are two normals, right? This is one normal and this is the second normal. The two normals make 180. 90 plus 90 becomes 180. So we can write here angle A plus angle Q and R. This angle. Angle A plus angle Q and R will be how much? Q and R will be equal to how much? 180 degrees. Here, because these two are normals, right? This one I'll draw with the other one. See here, and this one. They are 90 degrees, right? Yeah. So that is why this angle and this angle is how much? 180 degrees. Yeah. So now we can write. Yeah, very good. Now we have to take triangle QNR. Okay. Triangle QNR. What is that? Angle R1 plus angle R1 plus angle R2. Angle QNR. Very good. Angle QNR equal to how much? Sum of the angles in a triangle is 180 degrees. Now, so can we write angle R1 plus angle R2 equal to how much? Can we write 180 degree minus QNR? Yeah.
So angle A equal to
yeah. So let this be equation number 1. Let this be equation number 2. So what will happen now? From 1 and 2, what will happen? Can I write this QNR the other way? If I write this QNR the other way, angle A will be equal to 180 minus QNR. Yeah. So that will become what? Angle R1 plus angle R2 will become equal to angle A. Can I write like this? Yeah. See, 180 minus QNR is angle A. R1 plus R2 is 180 minus angle QNR. Okay. Here, or do you want to write that step? That is understood, right? Now, let this be equation number 3. Let this be equation number 3. Now, I want to find out this angle and this angle. Yeah. Okay. Before doing that, okay, let me discuss about the. Now, see, this is the extended incident ray. If there would not be any prism, the light would have gone in this way, right? And here also, if you extend this backward, the light is meeting at this point. Okay, this yeah, that is let that point be M. Okay, this angle is said to be angle of deviation. Angle of deviation is delta. Okay, here angle delta is angle of deviation. What is angle of deviation? Angle between the incident ray and the emergent ray. Yeah, extended incident and emergent ray is said to be angle of deviation. Yeah. See, once again, quickly see. ABC is a prism. AB and AC are the refracting surfaces. BC is the base of the prism. PQ is the incident ray. QR is the refracted ray. RS is the emergent ray. Now, here N is the normal. N1 is the normal to the surface AB. N2 is the normal to the surface AC. Both the normals are meeting at point N. Now, PQ is the incident ray, which is making an angle I with the normal, and R1 and R2 are the angle of refraction, which they are making with the two normals, and RS is the emergent ray, that is making an angle of emergence is E. Okay. Now, what is angle of deviation? Angle between the incident ray. Suppose if you extend this backward and this forward, then they meet at a particular point called M. So that is angle of deviation. Clear? Now, we started with a quadrilateral AQ1R. The sum of the angles in a quadrilateral is 360 degrees. But we already know that the angle between the two normals is 90 plus 90 makes 180. So therefore, angle A plus angle QNR is equal to 180 degrees. Therefore, angle A will become equal to how much? Angle A will become equal to 180 minus angle QNR. Okay. Angle QNR. So this I will make it from. Okay. And sum of the angles in a triangle equal to 180 degrees. So sum of the angles in a triangle equal to 180 degrees. So what will happen now? Angle R1 plus angle R2 plus angle QNR equal to 180 degrees. Just bring that QNR on the other side, then we get this. Okay. Equate both of them. Compare both the equations. You get it. Yeah. So now. So what is this angle? We'll just find out our angle. Now I want actually this is R1 and this is I. I just wanted to find out this angle and this angle. Okay. Is that clear? I want to find out this angle and this angle. Is that clear? So how much it could be? We will see that. Yeah. So angle delta. So exterior angle is equal to, sorry, this one. Exterior angle is equal to interior sum of the two interior opposite angles. This is exterior angle, right? Exterior angle is equal to sum of two interior opposite angles. So delta, angle delta will be, but how do we get this angle? If you subtract these two, you will get this angle. Okay, I will draw it a little bigger so that you will understand. So this is, these are the normals. This is A, Q, N, R. Okay, and this is the refracted angle. This is R1. This is R2. Okay. Now this is the angle of deviation. Okay. And here also this is delta. I want this angle and this angle. Okay. So this angle is how much now? Okay, we will take like this. This is I. No. This is E. Okay. So if I want this angle is I minus R1. Okay. I'm just subtracting these two. Is that clear? I minus R1 and this will become E minus R2. Is that clear, Ivar? Okay. Now I minus R1 and E minus R2. This is the value I got. Okay. Now I minus R1 and E minus R2. So now angle, exterior angle is equal to sum of two interior opposite angles. That is angle I. Okay, just write like this. Delta equal to I minus R1 plus E minus R. Is that clear? I minus R1 plus E minus R2. So delta equal to how much now? I plus E minus R1 plus R2. What is R1 plus R2 now? What is R1 plus R2? Yeah, A. So therefore, delta equal to I plus E minus capital E implies I plus E equal to A plus delta. Understood now? I plus E equal to A plus delta. Yeah. In case of font size, man. It's very small. So this is the first formula. Okay. Now we'll go with the angle of minimum deviation. Okay, or minimum deviation position. You know exactly how it is. Oh, I have a prism. Or something like a prism. Okay, something like a prism. Okay, when you are doing experiment, right, it will be like this. You just put it on the plate. Now, example. Okay, I'll take this. Now, think that this is my prism. Okay. Example, this is like a prism. The light incidence here, yeah. The light incidence here, and then you can see the light coming out from it, right? So this is the incident ray, and this is the emergent ray. Emergent ray is coming out in this way. Now, so at a particular angle of incidence, what will happen is the refracted ray grazes along, will become parallel to the surface of the two medium, the base of the prism, Refracted ray will become parallel to the base of the prism. Yeah, parallel to the base of the prism. And now, actually, what happens? How do we see this spectrum? So no one has seen, right, this one. How exactly in the lab how it looks like? I'll just tell you. If it is a monochromatic, okay. If it is a monochromatic, what will happen? Let's suppose we'll just see a line like this. Actually, you did with the pin, right? You did with the pin. Okay, that was a different thing. If you are using monochromatic light, we generally use in a dark room. Okay, like we say optics lab is a dark room. In that, what we do is we take monochromatic light. Yesterday I was discussing about monochromatic and polychromatic light. Monochromatic means single wavelength, only one color. The street lighting system, the street lighting, the street lighting system, we have monochromatic light. Okay, so the monochromatic light has only one color, yellow color light. What we are using, sodium vapor lamp has yellow color light. Whereas if you are going with polychromatic, it is multiple colors, so many colors. Okay, like white light is the best example of it. So when you really do this experiment in the lab, we generally use spectrometer, not the chemistry spectrometer. In physics also we have a spectrometer. Okay, like there is a round table on which we keep the prism, and there is a called collimator and telescope that I will explain. Okay, now when you look in when suppose this face is towards lamp is kept and there is a wooden box. Only a line is open, like a crossfire or something sometimes, or only a strip is open, a slit is open. That much light only will come out, and that much light only will fall onto the face. But when you see here, it will be only a fine line, very fine line, bright fine line, yellow line. Okay, now what happens is, okay, now you got the idea now? Okay, you will see a fine, bright, like this thing, that this line. Okay, now the what I mean, the spectrometer, when you look at the spectrometer is like a rotating table. It's like a rotating table. Like how it is, there is a think that there is a rotating one. It's not completely on that. There is the table is rotating, and the down one we have meter, like a circular meter. And there are two tubes, one here and one here. The one is collimator, from where the light will enter. Light will enter. Okay, that means it will make the beam parallel. That's the purpose of that collimator. And from here you can see there is a telescope also. Without telescope also you can see there is a bright line on very fine bright line. Generally in when you are using sodium vapor lamp, there are two lines actually. The two lines are 5890 angstroms or 589 nanometer and 5896 angstrom. 5890 angstroms and 5896 angstroms. There are two lines in two bright lines, very close to each other. Very close. They are same color, but only we have two wavelengths. That is because that is the reason why sodium vapor lamp is a standard. It is considered as a standard monochromatic one. Even though it should be one color, but still it is showing two different lines in it. Understood now? Now what happened is I am rotating the table slowly. Now what happens? This incident light is falling on this. Right? See, it was like this before. Slowly I am turning this. So what happens? The bright line starts moving like this. The bright line starts moving like this. When you started rotating this slowly, you're rotating this one. You're not touching the prism. There is a table. You're rotating the table. So what happens when the light incidents here? Earlier it was like this. So it starts moving like this. But when you still start moving, instead of going like this, it is coming back. You understood? When I was rotating, it was actually going like this. The line was going. Even if you start keeping on rotating, like it is coming back. Slowly coming back. The point at which it starts returning, that is said to be minimum deviation position. You got it? No. Okay. Actually, we cannot explain all this in the class, right? Okay, just they will say that is I is equal. That is at that situation, what is happening is R1 equal to R2 and I is equal to finish. They close the chapter. But actually, what is happening? When you are rotating, when you are rotating, it will go like this. Okay, when you are still rotating, it will start coming back. That situation where it started coming back is said to be minimum deviation position. At that point, what is happening? The refracted ray is becoming parallel to the base of the prism. Okay, and both the angles are equal. angle of reflection and angle of incidence both will become equal. Here, so we'll do that. Now, so here, what will happen in the so angle of minimum deviation equation. So delta equal to dm, we write. Delta equal to dm. Angle I will be equal to angle E, and angle R1 will become angle R2. So in that, it will become A will become equal to how much? So from the first equation, from 3, what will happen? A will become equal to R, or R equal to A by 2, right? R equal to A by 2. And now come to this one. Let this be equation number 4. Okay. Let this be equation number 4. From 4, what will happen now here? So A equal to, R is equal to A by 2. So dm equal to how much now? D will become dm. Dm equal to how much? Angle I equal to angle R. So it will become 2i. 2i minus A. Okay? Here, 2i minus A. So we can also write I is equal to what? 2i is equal to how much? dm plus A. So I is equal to how much? dm plus A upon 2. Okay?
So we can write A as 2R also, and then Dm is equal to 2 4 into 1 minus I minus 1.
Yeah, we can do, but why we are writing delta here? Is this clear? See, delta equal to dm, I is equal to E, R1 is equal to R2. Now, what happens here? A equal to 2R, R equal to A by 2, dm equal to, we are using the same formula and writing dm equal to 2i minus A. Now we have, refractive index formula. What is that? N21 equal to N2 by N1 equal to sin I by sin R. So, what is, so it will become what? Sin I by sin R is sin of A plus dm by 2. Sin of A plus dm by 2 divided by sin A by 2. Okay. So, this is the formula for the refractive index. N is equal to sin of A plus dm by 2 divided by sin of A by 2. If the angles are very small, sin theta will be equal to theta. Okay. If the angles are very small, sin theta will become equal to theta. So here what will happen here? If angles are if angle is small, sin theta will become equal to theta. So therefore, n equal to how much? A plus dm by 2 divided by A by 2. So what will happen now? N equal to n to 1, right? This is n to 1. N to 1 will become equal to 2 and 2 will get cancelled. A plus dm by 2 divided by A plus dm by A. So that will become n to 1 will become equal to 1 plus dm by A. Yeah. This is something like this. Or it's becoming n to 1 minus A. Or we will do like this. N to 1 equal to 1 plus dm by A. N to 1 minus 1 into A equal to dm. Okay. So this is one more formula for finding the angle of minimum deviation. Okay. So on what are the factors on which the angle of deviation depends, or angle of minimum deviation depends?
Angle of prism, then
Refractive index of the prism. It depends on the nature of the prism or refractive index of the prism. It also depends on the angle of the prism. Okay. So that is why we have this is the third formula, right? This is the second formula. This is the third formula. What was the first formula? I plus E equal to R1 plus A plus delta, right? Deviation A plus delta. This is the first one. The second one is N is equal to sin of A plus dm by 2 by sin A by 2. Third one is N21 minus A equal to here. So this completes your. Got the idea now? So you go to YouTube. You can just go to the experiment. What is that? Refraction free prism experiment, not the derivation. Like go to the experiment. They do in the dark room. Maybe someone have recorded this now. So you can see how it is. The spectrometer is like a rotating table. They rotate slowly. When they rotate automatically, what will happen? They're not touching the prism. Slowly, so automatically the light will go and it will start coming back. The point at which it starts returning back. That is set to the minimum deviation position. Okay. Now, can we start then instruments, optical instruments now? Let's see what. Yeah. Are you understanding?
Yeah.
Maybe this is the first time after long doing it outside class. Yeah. Almost for more than 100 of you, you're online with me.
Yeah.
So how much time was it taking yesterday to reach return home? No, while returning. From here you went back to your flight. How much time it took for you?
20 minutes.
So taxi, you took taxi. You also? You took taxi or how you took?
Chemistry sales.
No, not chemistry. Oh, from here you went to chemistry, right?
Yeah.
Now after that, when you are returning, how much did it take for you? 10 minutes. While coming, how much time it took from there, from your home to chemistry, sir?
It depends, like,
Depends
on the
on
time.
the time. If it's like late evening, then it takes more time. But if it's like afternoon, it's nothing.
So Friday, Saturday, Sunday will not be issue.
No,
That won't be issue. Only in the weekdays.
Yeah.
So we go. John, are you? Is it clear, Mr. John? Yeah. Okay. Now. Yeah. Turn off the AC. Turn off the AC.
Yeah.
Yes. They cannot tolerate. Now, optical instruments. So, in optical instruments, there are two types. One is only for this level. I just explained microscope and telescope. The microscope to simple and compound. In telescope, we have terrestrial and astronomical. Astronomical again too. Reflecting and refracting. Terrestrial only we have refracting. This is the classification. Optical instruments, microscopes, telescopes, in microscopes, simple compound, in terrestrial refracting, in astronomical reflecting and refracting. But in our syllabus, in our textbook we have simple compound. This is there and this is there. This is not there in our syllabus. This in our textbook. But again, in that also, I think they have deleted the refracting, terrestrial refracting. Is it deleted? Just check. Just one is deleted. Don't exactly. Yeah, that is microscopes, optical instrument, microscopes, and astronomical telescope reflecting and refracting, and their magnifying power. That means this is there. This is not there, right? These two are. Okay. So this is yesterday I was discussing. This is about the big lens, and this is about the big mirror. That's it. And this is simple and fast. Simple is very easy. Okay. This we have to only time takes in only understanding the normal adjustment position and image formulating. Image formulating. These two things will take time. Okay. Clear? Yes, Mr. John. John. Are you there? Oh, okay. Where is Joshua? He said he will be joining. Okay, now we'll go with microscope now. To understand microscope, in grade 10, there was convex lens, right? There are six figures for the right. In the sixth figure is the microscope.
The one that produces.
It is nothing but we are going to discuss in second microscope. We are going to discuss the sixth figure of the grade 10. What you say? Same example.
Very easy.
In simple words. You understood? Okay. So we will just do a recap of that. So convex lens, we have seen this was a convex lens, and now see here, this is the focal point. This is the center of curvature. We started from infinity. First was infinity. Second was beyond. This is second figure.
Beyond.
Yeah. Third figure. Yeah.
Between.
Fourth figure. Fifth figure.
Between
This we are going to discuss about this and this. There D and normal adjustment position, right? D and normal adjustment position. This we are going to discuss now. Now, simple microscope. Let's start with. Okay. In simple microscope, we have a lens. So, who is the object? OJ is the object. I am taking two rays. Yeah. The ray which is parallel to principal axis of refraction passes through the focal point. So, the second ray which goes straight. Yeah. Yeah, it goes straight. So when you extend it backwards, maybe somewhere here, these two rays are meeting and the image is formed. Okay. This is what? Virtual, erect, and magnified. Okay. So this is the nature of the image. So here U is the object distance and P is the image distance. Here V equal to D. So will it be positive or negative distances? Both will be negative. Right?
Both are negative.
Both are negative. So in say that is what do you call it? I mean the object distance and image distance both will be negative. Okay. Object distance and image distance both will be negative. I focused on near point. So here this is what I focused on near point. What time the search started at us?
He said 2:30, but then we started 2:45.
What are the school timings? Is it
No, he's not going to school.
But
We have spring break.
No,
We have
we're
2 weeks
spring
spring
break.
breaks.
All our practicals are over. So
that is the reason. Okay, got it.
One second.
Okay. So, what is the meaning of near point? That is the least distance. I
I can
focus.
see clearly.
Yeah, the least distance of distinct vision. Where the object can be seen clear. That is said to be near. We say not near point actually. The eye is focused on near point, but the image is formed at D. Least distance of distinct vision. Now, generally D value is image formed is at here, right? Image formed is at D. Image form is at D. Here D is how much? D is 25 centimeter. D is 25 centimeter. What is the formula for magnification? Magnification formula? M equal to V by U. I'm using V by U. That is okay. Before going to that, M equal to V by U. And we have formula 1 by F is equal to 1 by V minus 1 by U. Okay, 1 by F.
Lens is V by U and for mirror it's minus V by U.
No, I'll come to it. Yeah. Because it depends upon the image where the image is formed. You cannot say for this it will be minus. Both will be minus. Even minus V by minus U. Heights are also positive. H dash by H is also positive. Okay, yeah. So now,
So, but in mirrors, the formula itself is minus V by U.
that we write minus V by U. I'll come to that point. Just sign convention.
The sign convention, the formula itself for mirrors.
I'm not going with that. I'm just taking V by U and H dash by H. Later on, I will write minus and plus. That later on I will write. Okay. Because see, there are 4 situations now. One is convex lens, convex mirror. Sorry. Convex lens, concave lens, convex mirror, convex mirror. 4 situations are there. I will discuss all the 4 situations. If we complete this, I will discuss all the 4 situations. So that doubt should go away from your mind. The sign convention should not come in your mind now. Okay. Now, so we have this is a mirror formula, right? 1 by F is equal to 1 by V minus 1 by U. This is a mirror formula. So now, what will happen now here? So here, when I take 1 by U, implies 1 by U equal to 1 by V minus 1 by U. 1 by U equal to 1 by V minus 1 by U. Why I am doing like that? I am going to substitute here. In the place of U, I am going to substitute. So M will become equal to how much? M equal to V into 1 by V minus 1 by L. So that will become M equal to 1 minus V by L. If V equal to what? V equal to minus D. See now. Now I took minus D. Mr. Sayan. Now I took minus D. If I was taking minus before, then I should not make it plus minus again. So M equal to what? M equal to 1 plus D by L. This is the formula when the image is formed at D, least distance of distinct vision. This is the minimum distance of the eye from distance of the distance between the object and the eye. Okay, where you can see the object clearly without any pain. So some students they go very close to the notebook and they write. It's painful. See, if you keep any object like this, it's okay. You can read for a long time. Like this also you can read, but it's painful. 7 to 8 centimeters is a near point. This is least distance of distinct vision. This is near point, 7 to 8. It's painful, but still you can see, but it's painful. You cannot see, you cannot read that for a long time. Okay. Now that is near point. Near point is 7 to 8 centimeter. Least distance of distinct vision is 25 centimeter. Okay. Now here we'll discuss one. Now suppose, now I go with normal adjustment position. What is normal adjustment position? Normal adjustment position. Normal adjustment position means, suppose I am working in a lab, like medical lab or something. So I have to, from morning to evening, I am like the whole day I am playing, I am working with the instruments. So we have to adjust the image such that it is formed. We have to adjust the lenses in such a way that image is formed at infinity. Image is formed at infinity. Then the whole day you work, it won't be painful. Yeah. So like you are adjusting the lens in such a way that the image is formed at infinity. That adjustment is said to be normal adjustment position. Yeah. So adjusting the lens, adjusting the lens in such a way that the image is formed at infinity. Image is formed at infinity. So you can throughout the day you work. So generally, in research laboratories or medical laboratories, those the people who are working there, they go with normal adjustment. They never go with D. Then when do we go with D? When you are working in the lab, for example, if you go to medical bio lab, they are doing with D. They don't go with D. No, understood. They go, are a bio student or computer student? Good. So away from the creators. It's very difficult. I don't know how the bio people do. Yeah.
You have maths.
Huh? They don't have
You have maths.
math. You need logic to remember.
Yeah.
No, math goes with logic.
That's
Bio
what she
you
doesn't
need-
have.
Huh?
That's what she doesn't have.
Math, I don't know.
So you're bio and computer student.
Bio and psychology.
Oh, yes, I know. These people are like this. They keep on reading the people. Wherever they go, how is it? That's it. Yeah, I have uncle. He's a psychology lecturer. In fact, I keep on reading. I keep on confusing. So, that's it. But you need to learn so many scientists and all, no? But it's too much. No, even we had in BEd also. The psychology. Just children's psychology, child psychology, what they say. Like every scientist had a different conception of way understanding the. They did experiments again.
That's all.
They did on humans and animals and all like that. Yeah, it was but it was good because of that only we are able to assess and all. But recently I came to know that like internationally also they are removing the mark system. Is it true? This guys got sent there to like in India, like next year onwards, they want to go with an entrance test
Oh yeah.
in India. Is it no foreign also?
No.
That's what I.
Only India, the big universities like
Maybe
University
like
of
for
Delhi,
engineering.
Yeah.
like those the top universities.
I told you, the cutoff marks.
Yeah, 100.
Did you check online? You should have checked this one.
year, I don't know.
Stephen College, Delhi University, many colleges.
IIT will be.
No, IIT doesn't go with marks.
They go with JE, but JE was also very high last time.
You can't score that much. And physics is the deciding factor, you know. You get 100% in math and chemistry, but you won't get. Physics is the deciding factor everywhere. That is like that. Physics is that. Okay, now So normal adjustment question, we go with that. Here with this one. Now, what we are doing is just a minute. So here, suppose when the object is at focal point, what will happen? See here. This is passing through focal point. So these rays will become parallel. They join somewhere in between. These two will become parallel. If extended backward also, they are parallel to each other. Here it was not like that the previous one.
Okay,
They met at a particular point. They were little diverging, so that is the reason they met at a point backward. But in this case, we are adjusting the lens in such a way that the image is formed at F. Actually, to be frank, the first figure is sixth figure and this is fifth figure.
Fifth figure.
Sorry. This is the fifth figure of last year. So, John,
He told me he had cut out.
he's taking practical so seriously, man. Who takes practical seriously? Study for a day and leave it, okay?
Our teachers make it such a big deal. They'll give us full marks, but still they'll be like, if you don't study, then.
In mathematics, they conduct test and all.
Sir, we got to know our maths board exam was like one day before it actually was. Like one night before.
Board means practical, you know.
Maths board practical we got to know that the
You
dates
prepared for
on
that? You prepared for that?
yeah for 2 hours one night before. We got to know only the night
The
before.
last chance between yes or no. So then just prepare one activity, come and write finish.
In our school they take it so seriously. We were making
It
chits
depends
and
on the perspective.
so they made like
So here, this is that means this is the fifth figure of your diagram where the image is formed at infinity. So here, we use this formula. Here, this is we are writing theta I. Okay, angle of incidence is theta I. Okay, and this is also theta I. Theta I is set to be the angle of incidence. Now tan theta equal to what? This is h. The previous one, we write theta 0. Okay, the previous one. I'll go to the previous diagram. This is h, and this is theta 0. You took theta 0. You can take alpha or beta also, not a problem. I'm going with the textbook language. Okay. So if you go to exam idea, it will be different. If you go to Pradeep, it is different. If you go to another book, it is different. See, I suggest you don't go with for any subject. Don't go with exam idea or OSWAL. Don't go with that. I found many mistakes. That's what I'm doing. Just for physics, Pradeep is good. Physics, Pradeep is good. And mathematics, addition math. What is their addition math? Let me tell you. These are the solutions of full textbook, solutions of the exam block, and few solved papers. That's it. That makes addition.
the book itself is double in size.
Yeah.
I did addition and then after that I gave it.
Now nobody is using it. Now it has come down. The users have come down.
But no one wants that much. In 10th, still people use. Now in 11th, 12th, no one uses.
Now students know how to scan the questions. You know there is a software also. Just scan it, you get that. Yeah. What is it? Math scan math something is there. Some software is there. Just scan that.
There are so many. You go online, you go on App Store, so many.
Yeah, not just with you write in your own handwriting and just scan it. Just it will scan it, convert it into a question, and then it will give the answer also. It's so easy. Right. Now, so here the formula here is tan theta 0 equal to what? H on D. So we can also write this is equal to theta 0. Theta 0 is the maximum angle. And we have magnification formula. What is that? M equal to h dash by h, which is also equal to v by v. In this case only, in this case only, the previous case only. In the previous case, image is erect, magnified, and virtual. Means heights are also positive as well as both the distances are negative. Both are negative. So that is the reason I took here h dash which is equal to e1 in this case only. Now tan theta I is equal to how much? Tan theta I equal to we have h dash by minus v. Can we write like this? H dash by minus v. Or it is also equal to, see here, what is theta I here? Can I take the new figure as h dash? If I take h dash, opposite circle, adjacent circle. Should be f, right? Here it should be f. So what is h dash here? H dash is equal to h into v by u. Okay, I am not taking f now for time being. I am writing only v now. Okay, I am writing only v. H dash by v. So now what will happen? H dash is what? H v by u into minus u into v. V and v will get cancelled. So answer is what? H by minus f. Okay, h by f. U is equal to f. Okay, is that clear? U equal to f. Now so magnification formula is what? Magnification formula is theta I by theta O. So theta I is equal to what? Theta I is here I am writing d by r. How come? Can you tell me? I write here d by r. Magnification formula is I write theta I by theta 0 is equal to d by r. Or forget about it. Just not to make it confusing. I'll write for the simple one. I'll write m equal to d by f. This is the formula for when the image is found at infinity. When the image is found at infinity. Yep. Understood now? See once again from the beginning. We have the magnification formula h dash by h. Okay. That is v by u. Just cross multiply, we get this. So what is tan theta I? It is equal to opposite by adjacent side. So just substitute that, we'll get h by h. H is here I am taking. Okay, just leave it like that. The magnification formula here is what? M is equal to d by f. Okay, m equal to d by f. That is d is the least distance of distinct distance. Okay. What do you mean by angular magnification? What do you mean by angular magnification? Your linear magnification, angular magnification. What is the definition of angular magnification?
So this height is there. When your height increases, this angle also increases. Like theta I also increases.
What is linear magnification? Magnification is size of the image by
Is magnified.
size of the image by size of the
Size of object.
M is equal to H dash raised to D by D. Okay. Angular magnification. This is medium angle. Angle subtended by image.
And this is by
Object. Just click on.
ratio.
Yeah. And see. Like this, tan theta I divided by tan theta 0. So because the angles are small, so we are taking that theta I by theta naught. I for image, O for object. Understood now? I for image, O for object. That is conversion. Just draw the figure and write that. In examination, you are not going to do all these things. In examination, you are going to just draw the figures, like the magnification formula they ask. Finish. That's what I have. Yeah, but you should know the difference. The diagram for D is different from the diagram for infinity. Normal adjustment. So be clear with this. And why do we use that? You also know normal adjustment, but why it is important. To be frank, you should have two figures here also. Right now. You should have two figures here also, right? One is for D and one is for normal. Even for this also, one is for D and one for normal. But are we doing that? Are we doing that? Yeah, we have. I just showed you that. In one of the books, I have that. This like this.
So it will be there for JEE, right?
Yeah, it will be there. But I will just show you how it is. Then only you will understand actually what we are doing. That why it is confusing, that is the reason. Here it is. This is here. This is for simple method, right? This is when the image is formed at D. Okay, this is the derivation chapter. This is when the image is formed at infinity. Actually, this whole derivation is not very good. That's the reason why it is confusing. Actually, the derivation comes in this way. This is different and this is different. This is only for simple. Compound microscope, when the now see here, this is when it is formed at D. This is when it is formed at infinity. Two figures are there.
Only in the textbook they are only given for infinity, compound microscope.
No. I will tell you. Now you can now see. They give for D.
D, okay. They didn't give you.
But even though if they have given for D, see, if they would have given for D, the two rays, see, is it parallel? Yeah, see. Yeah, this is the D. Actual figure is like this. Here they meet actually, they become parallel. See, but this fellow he didn't do that. This is the way where the student get confused why it is like that.
Yeah.
Where you are all physics, optics lost in here. Actually.
So if we draw this, we get marks.
This is the right way of drawing the figure. Because once the image is formed, we are taking two rays, one parallel and one passes to center. Then only they will meet.
I lost marks for this in my models.
Not only you, many students also. We got it now. He said D, but D figure should be like this.
Yeah.
Got it. So that is why I will be struggling with the book, you know. That's why I have a very good collection of books. So I keep on searching for a proper diagram. See, this is the actual diagram. See, we need two rays here. Up to here it was correct.
But then they should.
Up to here it was perfect.
Yeah.
But here he messed up.
Yeah.
Actually, there should be two rays, one parallel,
And
one center. And second one you see, for infinity, how it is. So these two rays, they became parallel. See, got it? Again in telescope also, see. This is when the image is formed at D, infinity, and this is D. See, image is formed at infinity, image is formed at D. There are two different figures. Now we will go to your textbook for the telescope. Let us see what he has drawn. What he did here. See, this is for what? And the image is formed at infinity. This figure. But this figure, see,
Yeah, the
he messed up here also.
Yeah.
Got it? He messed up here also. It should be like this.
Yeah, because it should go through O, but it's not.
Yeah, it's not complete.
Got it now?
That's why I lost 3 marks for this for no reason, man.
Understood.
Correct.
So we will do exactly this figure.
Yeah.
One figure for telescope and this figure for microscope, right?
Yeah, but in CBSE will they cut marks for
No. Jacob will go and see. Don't worry. Okay, I'll also come.
So because in models for this I lost, like she actually.
What do you mean by this? There should be some sense in drawing,
Yes, I
right?
asked ma'am. She was like, but this is how it's given in the textbook.
Which one? She
This
drew
one.
like this?
No, I drew like this.
Then?
And then she drew like the one in textbook. Like the 2 rays one.
No, you should have told ma'am. What is
I
wrong?
told ma'am, she's like, it's like this in the textbook, so I didn't argue also.
No, it's not like our game. We are asking for rights. Yeah. No, it should make sense, right?
Yeah.
Ah. So that's the thing. The reflecting is like this. See, this is the reflecting. Actually, it is like this. The reflecting is perfect. It's not not a. But actually, this will include. That's our problem.
The back.
The back image is formed here. This is
Yeah.
deleted. This is the thing. The image is formed here. This is classic ray. Okay, but there was one more Newtonian. It was like this. This is not there in our syllabus. There are reflecting also. There are two. Reflecting there are two. One is Newtonian, one is classic ray. But we are doing only classic ray. Okay, the classic ray only. Yes. So we will see how it. Too much, no? They messed up and then yeah. So okay. That is how it confuses. Yeah, you got tired? Huh? Just to take 2 minutes break. We'll again just relax for some time. Then I'll start with compound microscope. Okay? Yes, Mr. John. Are you there, John? John, are you there? John, are you there? Okay. Now, so I'm going with this one. So 2 rays, a ray which is parallel to principal axis will pass through the focal point. It passes through the focal point. Second ray which passes through optic center goes undeviated. So they meet here. This is A double dash and B double dash. Okay. This is U. This is FO, focal length of objective. This is FE, focal length of iris. This is H dash. This is beta. This is also beta. Okay. That's it. And this is B. This value. See once again. This is the objective lens. There are 2 lenses, objective and eye lens. Lens which is focusing toward the object is objective. And the lens which is close to the eye is said to be eye lens. Now, AB is the object. Okay, first draw that. Draw. Finish the drawing, then we will discuss. there are two lenses, O for objective lens, E for eye lens, or eyepiece. The lens which is towards object is known as objective lens. Lens which is close to the eye is said to be eye lens or eyepiece. AB is said to be what? AB is said to be the object. You are taking two rays, a ray which is parallel to lens axis passes through focal point. Second ray which passes through optic center goes undeviated. Okay. Now what happens here? The image is formed. H is the size of the object. H dash is the size of the image according to this one. Now for this lens, this will become object. The image of object becomes object to the eye lens. So now take two rays, a ray which is parallel to lens axis passes through focal point. Second ray passes through optic center goes undeviated. Retrace the path, it is meeting at a point here. Where it is forming image A dash and B dash. This is a D. This distance of distinct region. Okay. Now we have angles here. FOC, V is the object distance. FO is the focal length of the objective. FE is the focal length of the eye lens. Okay. now we have MO. MO is what? Magnification of objective. Okay. H dash by H. Can you write like this? Magnification of objective. H dash by H. So that is equal to what? That is equal to, suppose if you place, that is equal to V by U, right? These two lenses are mounted in a barrel. These two lenses are mounted in a cylindrical barrel. Tube or barrel we say. Cylindrical tube or cylindrical barrel. So now suppose if the distance was F here, the image would be here. If the object was here, image would be very close to the lens. Understood? Means exactly equal to the length of the barrel. Yeah. B used to be this much, right? What is this? This is nothing but the length of the barrel. Okay. So here H dash equal to L by FO. Yeah. So this is the value. Now here we have now invert this one. H by H dash, which is equal to FO by L. H by H dash equal to FO by L, and H is equal to what? H is equal to cross multiply H dash into FO by L. Is that clear? Is that clear? Okay. Now tan beta, here it is beta. What is the formula? Tan beta is equal to opposite side by adjacent side. So tan beta equal to opposite by adjacent side. So what is H dash? H is equal to what? H dash into FO by FO into L. This and this will go away. H dash by L is the answer. Okay. So this is for the objective. We are done with the objective. Now we go with eye lens. Eye lens is like a simple microscope now. In simple microscope, when the image is found at D, what is the formula? 1 plus?
1 plus 2.
Very good, that's it. 1 plus D by Fe. Can you write Fe? 1 plus D by Fe. Now, when the image is ME equal to what? D by Fe, if image is at infinity, right? Image is at infinity. We got the difference, right? You know the difference now?
Yes.
What is a normal adjustment position and what is deposition? So the total magnification is how much now? Total magnification for combination of lenses. What is that? M equal to ME, total is ME. M equal to ME into MO. Okay. So now M equal to what? M equal to L by F. L by FO into what is MO? So MO we got. ME is D by FE. Okay. M equal to D by FE. This is the formula. Their total magnification formula. It is the length of the barrel or length of the cylindrical tube. FO is the focal length of the objective. F is the focal length of the eye lens. D is the distance of distinct region. 25 centimeter. Just substitute the values. We will get the magnification of the compound microscope. Here, we will just do a simple numerical here. If FO equal to 1 centimeter, Fe equal to 2 centimeter. Length of the barrel is 20 centimeter. When you solve this problem, when you find out the magnification, how much time it will magnify? Just substitute in the form.
So maybe get L by from the last one.
L by this is from here. Magnification of objective. Actually, this is not even required. You know, this is not even required in the this concept. From here to here, this is not required actually. This whole thing, these 3 steps, are not even required also. This is only magnification, angular magnification. We're not using it, but only directly this one, then this one, then this one. Finish. You can do it. Yeah. So just remember this formula: magnification of compound microscope is L by Fo into D by Fe. Substitute the value, get that. Just find out this magnification value. All are in centimeters. You need to convert into meters. How much? 250 times. What is the unit for this?
Centimeter.
Magnification doesn't mean unit. That is why when you if you go to the lab near the eyepiece, it will be like 10x. Did you notice this?
Yes.
10x,
100x.
100x. The meaning is 10 times more.
Okay.
Even on your camera, if you see the camera, the I mean the DSLR or something, there will be numbers on that one.
Yeah.
100x, 0.5 centimeter. Lens, then the focal length as well as its magnification is also printed on that one. You know, on there it will be there on the metal one, 10x, 20x, means x10, means that many times it can magnify. That's what now. X100 means generally compound microscope will go to 100 to 1000. Okay. So we'll stop here for today. Okay. So tomorrow we'll go with the telescopes and then we'll start with the text.
So open.
Same 5 is okay? Did you understand, Mr. Ram? I think there is one more book there. This is also there. You can take this.
So I'm going to kind
You already have physics. The new one is also coming. This physics I have sent you. Right? Try to solve it, but not now. After some time. Once you're done with this one, we can start. Okay, then. Take it. Okay, John, bye.